Sir, it is start.
So my screen is visible and we are moving to the board. So what I'm going to talk about is, first one is a fast VM cloning tool. Then we are going to talk about a bit about Docker and C groups. And third thing which I would like to talk today is whether one should move to cloud. These are the three objectives for today's session. I'll go one by one on each one of them, spending around equal time. Maybe on the last the third topic we'll spend little more time. The first thing is a fast VM cloning tool. So you all have installed virtual machines, and we know that all the hypervisors support different kinds of VM formats: VMDK, .vdi, .xvda. Right? These are the formats of virtual machine disks or complete VM, which you call. Now, in cloud, I may want to start large number of similar sort of VMs quickly. I have one web server running. I want 10 instances of same web server be running within no time, right? This is, as we said, this is part of scaling, right? Scaling. And we know that scaling can be done in two perspectives, horizontal and vertical, right? So when you want to scale, you should have these virtual machine instances be ready, right? So how do you copy them quickly is the first thing. So when I want to create a VM disk, I allocate blocks in the disk. When I'm copying it, I'm again allocating blocks in the disk, right? So if there is a disk of, let us say, 10 GB. So when we talk about VMs, it is actually a file on the disk. And when you are doing cloning, what you are doing, you are creating a replica of the same thing. So it should be completely byte to byte similar. You will get another file, which is a replica of the first file, right? So can we do this thing parallelly? Copying parallelly? Can this be done to save time? I have to copy a 10 GB file and create another replica of 10 GB file. Can I do it parallelly so that the amount of time required for copying is minimized? Is copying a parallel process? So copying involves reading and writing. Yes, reading from one place, writing to another place is copying. Do you think this can be done parallelly? Suppose this is the 1 GB file I have, and bytes are written one after the another. Multiple bytes are written. I need to create another copy having the same set of bytes. So I will read the first byte, write it here. I'll read the second byte, write it here. Another idea can be one of the thread is reading from here, writing there. Another thread is reading from here and writing here. I think this can be done parallelly. Yes?
Yes, sir.
And if I divide this work into 10 pieces, 20 pieces, those many number of threads can work. So one idea is you can create fast cloner by creating threads. Second idea is at what level, what system parameters should be chosen so that the VM cloning is more faster. So, we have certain specific hardware resources in our machine. If they are optimized properly, we can have very fast cloning, right? So I'm going to talk about this using this very good paper by one student. I hope this is visible. VM Cloner, a fast and flexible virtual machine cloner. This was published in CDC in Germany. The student did her MS from Carnegie Mellon University after doing BTech. And a lot of hard work has gone into creating this VM Cloner tool. What it is, it is a tool which can create multiple copies instantly, right? Now, this is a marketing term, instantly, multiple copies, but what is the real technology behind it? What are the parameters which need to be set is what we are interested in. So let us quickly read this. VM Cloner, which is the name of the tool, robustly clones a VM into multiple copies which are thereafter placed on different hosts, avoiding the downtime incurred in installing the operating system for preparing the cloned VM to complete a specified task. The clones share the same initial state. VM Cloner provides cloning of virtual machines with large virtual disks in a matter of seconds, fixes the issue of scalability by deploying thousands of VMs, and finally maximizes resource utilization. Right? This is the aim of the cloud. They want to scale quickly. They want to have so many virtual machines within no time. Right? Now, there are a few terms which are important. The term is virtual appliance. We all know what is a virtual appliance, right? It is the state of a real appliance, the contents of the appliance disks, as well as description of the hardware, like how much RAM it requires, how much disk is. So a virtual machine disk is actually virtual machine appliance, right? In addition, you require some additional things, like that when VM should run, how many CPUs, what should be the RAM, what should the disk which should be loaded. A virtual appliance may include a fully functional LAMP. LAMP server we know, right? This is the most common web server, LAMP server, Linux, Apache, MySQL, PHP. So this is a good example of virtual appliance. So a VM disk which carries this can quickly start a website. We have open virtualization format to support virtual appliances, right? Let us quickly come to the problem, cloning of a virtual machine, right? So a copy of a virtual machine image is called a VM clone. The virtual machine from which it is created is called the parent or the master. So how do you clone? Checkpointing is another area where cloning can prove useful by creating full-fledged clones at different points in time and rolling back to recover in case of a failure. I hope you can recall our last meeting, cloning snapshot we discussed, right? So there also we required copying, right? There are two ways. One is online cloning and another one is offline cloning, right? Let me make it in presentation mode, right? So on VirtualBox, if you clone different sizes of the disk, this is the amount of time you require. 2 GB, 27 seconds, 32 GB, 15 minutes, 34 seconds, right? On a specific machine, this required this much time on a SATA disk. Now there are multiple experiments which we have conducted to see what can be done in a better way, right? So on VirtualBox, you have some utilities, clone VM, clone HD, right? They can create duplicates, right, or replicas. So first experiment is knowing the time, how much time does it take to copy different kinds of disks. We are interested in changing these variables. You see there are 5 variables listed: transfer bitrate, block size, kernel page size, disk cache size, and buffer size. We identified these 5 variables on an operating system. If they are changed, cloning time differs, right? After these 5 variables, we also created threads to make it a parallel cloner. What is experiment 2? The objective of the experiment 2 is to examine the time taken to clone a VM with different sizes of virtual disks using a block by block sequential copying method. Pick a block, copy it, pick a block, copy it, right? So this is the amount of time you require, different block sizes and time. 2 GB disk from 62 seconds to 43 seconds. This is the amount of time you are taking, right? Different depend upon the buffer size. 4 GB disk, this is the amount of time taken. So it makes sense, right? There are things which are changing. Experiment 3, we introduce threads. Multiple threads can be run simultaneously on a multi-core CPU, which helps in reducing the time to complete a task. So POSIX threads, you might have aware, P threads, which we call them, this is done. So when you run threads, the amount of time taken is very small, 9 seconds to 11 seconds. Quite good parallelism is achieved, right? 4 GB, the time is larger, but with buffer size, it is also changing. You are going from 39 seconds to 52, right? Changing the number of threads also gives you different times, because number of threads may be good, may be bad. You should have the hardware to run those many threads parallel. So number of threads they have changed. The next factor is disk cache. This is very important factor, how much cache you have in the disk. So the size of the disk cache plays a prominent role in the process of reading and writing of files, as it provides fast memory access. The disk cache has been included in this experiment because it can greatly alter the time to copy a file. This is because the size of the disk cache is specified and fixed at the time of the creation. When the disk is created, it is fixed. Hence, the disk cache can only be manipulated in terms of it being cleared every time an instance of VM cloner is executed. So this is one shortcoming that you need to change again, make changes and restart the whole thing. The last thing which we changed is, can we go for bigger block sizes? And if we can go for bigger block sizes, can we improve it? So from 4 KB to 1 MB, the block size was varied. And you see the time required is around 6 seconds for a 2 GB disk, right? Even further improvement is there. So this is a complete cloner written by changing and optimizing the parameters where it is fitting best. And how many threads do you should run, because number of processors, or I should say number of cores multiplied by 2, that should be the ideal idea of running number of threads, because if you run more threads, their creation and termination overhead will be high, right? So it is not true that you can run any number of threads and you will always be doing good, right? There are a few additional things. You might know some of the very good copying tools already available. RoboCopy, rsync, it's a very popular mechanism of syncing files. Rich copy, they all are available. Copy on write, we all know what copy on write is, right? So parent and child processes, you remember, after forking child is created. But in copy on write, what we do is we don't create a copy of parent in the main memory. We keep on referring to the same copy of parent in the child, so that main memory is optimized, right? Only one copy, 2 processes can run. Similarly, when we do this in the disk, we can keep one copy of a VM and all the other VMs can refer to that disk data. I hope you remember in OS virtualization, I said this, that Solaris, we run these containers by using single kernel image, right? So these are some additional points which you may want to read, which are related to this, but this is what VM cloner is. So let me go back. Please stop me if you have any questions, anything which you think can even further improve this. I always welcome those ideas, right? Okay. Now the next thing I'm going to go is Docker and C groups. Docker, C groups. You might have heard these names of Docker containers, right? So would anybody like to say something about containers? क्या होते हैं container? नाम सुना है, काम में लिए हैं, या किसी application के लिए देखा है? What are containers and how they are different from virtual machines? Anybody? No one? Okay. So let me ask some specific questions. Suppose a customer comes up and says, sir, I want an environment which can provide isolated isolated resources plus some additional guidelines like number of CPU cycles per second plus so customer is saying that I want a VM which because you say VM will be given 2 CPUs. The customer saying that I want something more, right? 2 CPUs and maximum number of CPU cycles you define, that not more than 1 million cycles per second should be given to that VM. Second thing is the max disk speed should be 80 Mbps. Okay, plus it should not run on CPU 0 and 3. Suppose there are 4 CPUs, then it should not run on CPU 0 and 3. Suppose these kind of requirements, come, then virtual machines do not provide such requirements. Virtual machines can talk about CPUs, number of CPUs, size of the disk, etc. But going beyond that, further restriction on the kind of limits or resources are provided that cannot be governed by, virtual machines. Another thing which is problematic there is a better isolation. We know that virtual machines provide isolation, but we saw the example in the case of virtual machine UJS-based placement. I hope you remember that work. There we identified that two same resource using VMs affect each other because they have common resource interest. So whatever requirements I have said here, 3 requirements, similar examples can be drafted, plus better isolation. If you want this, then that cannot be provided by virtual machines, but a new environment that is not new, but new wrapper, old book, can be provided by containers, right? So some people, when we ask them what are containers, they will say containers are lightweight, isolated environments. So the answer is correct, but I would say that more finer grain resource restrictions, if they can be applied, then they can be applied using containers, right? So can containers and VMs coexist? Yes. On a physical server, you create multiple VMs. Inside a VM, you create containers, right? So that can be done. Second thing is why containers are becoming so popular today. Every web server is running container, right? They might or might not be running virtual machines, but they are running containers. So the reason is microservices. Microservices. So has anybody created any website? किसी ने कोई website बनाई है? Yes, Yukta. Have you created any website, any web pages ever?
No, sir.
No. Do you know any web programming language? See, I'm not going to ask you a question, right? Don't worry. If you have created any web page, please say yes. Basic HTML you might be aware, right?
Yes, sir.
Basic HTML you are aware. Do you know any names of the web servers where we can create websites?
Sir, like React and all that?
Yes. So you have heard about React. You have heard about Apache?
Yes, sir. A little bit.
Nginx you have heard about?
Sorry, sir?
Yes. Nginx.
No, sir. I have not heard about it.
You have not heard, but Apache you have heard, right?
Yeah, yes. Sir.
Okay, so Apache is a web server. Okay, and when you run web server, you actually run a process known as Apache 2 on an operating system. That process will keep on serving the request by serving them HTML pages, by running PHP scripts, by sending client-side JavaScript. So right now, I'm using this Giant mode, right? So there is a web server running there. I'm sending requests and responses are coming back. each Apache server is, it has a size, right? Size in the main memory. So Apache process may, start from 50 MB to 500 MB based on the size of the website. The effort today is to make lightweight server processes. Lightweight. When you say lightweight, it doesn't mean the physical weight, but memory snippet. In the memory, the size should be small. So containers today are, very much useful for creating microservices. Let me take an example of microservice. A web server running Ubuntu. On top of it, Apache is running. Database is MySQL, right? Okay, these three things are sufficient. Ubuntu, Apache plus MySQL. If I install the whole thing on a machine, it will take, some disk, right? Around 3 to 4 GB of the disk if I install the complete versions. And when I run them, it will occupy main memory because that much amount of main memory is required to run Ubuntu, Apache, MySQL, even Apache multiple processes will run. Now, after container came, a new idea came that, sir, we will run all these three things in multiple containers. Container 1, container 2, container 3, all running on a VM. And each of these container is running Apache 2 plus MySQL on Ubuntu. But in a very small memory size. How is this possible? So almost all Ubuntu, Apache, and MySQL, we will make them thinner. We will remove unnecessary things. We will only keep the main code. This is known as image. And we'll keep them in the containers. So Apache 2, MySQL plus Ubuntu in one container. From 4 GB, we will directly come to 400 MB and even lesser than that. So what we require? We require micro versions of these software. And that is doable. So containers will run these things separately. Why 3 containers? I will run these 3 pieces of software in 3 different containers. They will keep on serving different customers, right? So container will provide them isolated environments, lightweight images of Ubuntu, Apache, and MySQL. So there are 2 things happening: microservices. Second thing is better isolation. And third thing, which is quite related, I should not say it is third. Can we provide finer grain resource allocation? Like container 1 should not use more than 80 Mbps for the disk, right? Now the question comes up, sir, why you want to restrict the speed? See, I want to restrict the speed so that other processes get equal resources or enough resources, right? Second thing is, I don't want that only Apache should take all the resources. Other services are also running. Or I want that minimum 80 Mbps should be guaranteed for Apache. That is a second side of the coin, which I can see. So these are containers, right? Now, what is, when we go to the market, we get multiple different technologies in containers, in which 2 are very popular. One is Docker. Do you know the second one? Which is the most popular container in the after Docker? Kubernetes. नाम सुना है किसी ने? Docker and Kubernetes का किसी ने भी नहीं सुना है? सुना है सर. नाम सुना है. Okay. So Docker is a containerized environment. Kubernetes is also a containerized environment. Very small difference. When we talk about Docker, I'm talking about a single machine here running containers. But when we talk about servers, we have multiple machines actually running together, serving requests. So 3 to 4 machines, 5 machines, and they're running containers. There is one master, multiple slaves, right? Such a cluster environment is known as Docker Swarm. Docker Swarm. And Kubernetes already provide a clustered environment. So you can run Docker containers or Kubernetes based on your choice. So this is a good technology. I wish that all students should learn this, or the whole industry is using this. If you have Docker containers, Kubernetes, and experience with them on your CV, it gives you an edge. So this is a brief about Docker. Now let me talk about what is the underlying technology behind the Docker. क्योंकि मार्केट में हम जाते हैं तो हमें कंटेनर सुनाई देता है, but ultimately this is an operating system related technology. And what is that? See, Docker is governed by a very interesting stuff on operating system known as C groups, or we call them control groups. C groups or control groups. What are control groups? Control groups are process groups. So right now, if I look at my task manager, there are 100 processes running. 100, 120, 130. Can I create groups where some processes are in some group, other processes are in other group? There may be any basis of the group, like the kind of resources they access, kind of the nature of the application they run. I have created multiple groups. Now I'm saying that control groups. So what additional thing comes up other than groups? These requirements. Applying restrictions on them. If I can control those groups, then all the processes running inside those groups will follow these parameters. They will not be able to go outside. Operating system will stop them from using resources more than what is defined. This is the underlying technology behind the containers, right? Control groups. This is a Linux thing known as C groups, right? In addition to C groups, second thing is this microservices, very lightweight services. C groups plus lightweight services. Now, how to organize these lightweight services? Do you require anything? Yes, we require a file system, right? Thin images we require, right? So all such thing is provided by Docker, right? So let me go to certain documents which will provide you an help. First thing is C groups. Okay, this is a good write-up I have already made available, right? If you find it boring, it's a big write-up, don't read it. Let us directly come to how C groups can be installed. So I have done this installation on my machine. You can follow this and you can install C groups on any Linux machine, and you will be able to learn how C groups are run. So just now I told you that C groups are control groups, creating multiple process groups and then applying restrictions on top of them. So what we do? We first install the C groups. Remember, we are installing C groups. We are not installing Docker container. If you want to install Docker container, there are separate steps. They automatically install C groups behind the curtain. But right now, I'm only installing C groups. apt get install, C group lite, libc group 1, and C group bin. These are the three, dpkg packages we install. Once they are installed, you can mount the C group file system so that your operating system follows C group terminology. This command will mount all the resource folders such as CPU, memory disk. Disk is known as bulk IO. Why bulk IO? It sends and receives data in bulk in the block form, or multiple blocks or smaller number of bytes, but it is not a sequential device. And network, right? So once you do this installation, you will find a folder, this folder on your machine. It will be automatically created. sys fs C groups. Inside this, there are multiple folders, at least 4 of them, whose name are CPU, memory, disk, network. Why these folders are created? So that you apply restrictions in each of the basic resource, because on a computer there are 4 basic resources: CPU, memory, disk, and network. So you can create a control group and apply restrictions on such resources. How? So this I'm skipping something so that we know the real thing. sys fsc group, and there is a folder already available: CPU set, memory, bulk IO, and network IO. This whole thing is available. Now what I'm doing is I'm creating subfolders inside it, and name of the subfolders are this. You can create mkdir, create a folder. So I have written the command mkdir, Inside CPU set, I have created a folder known as 1V, 512M, 10D, and 1N. So you can see the name 1V CPU, 512 memory, 10 GB of disk, and 1 NIC adapter. You can create any name. I did this to explain you that I will apply these restrictions later. Once you have created this, what we need to do? We need to apply restrictions. So let us apply the restrictions. The first restriction is CPU set.CPUs. I am saying echo 0. When I say echo 0 into this file, what will happen? This 0 will be appended to this file at the end. Okay. When I say echo 0 again CPU set.mems, it means 0th processor should only be used. How many processors I have? Let us say I have 4 core machine. Then 0, 1, 2, 3. There are 4 processors. 0, 1, 2, 3. I am saying processor number 0 should be assigned to this control group. Only processor number 0. How much RAM? 512 MB RAM. Memory limit in bytes. This file I am echoing. Echoing means printing this value into this file will be done. What we should do? We should do the real thing. All those processors which we want to move into this control group, so that they cannot use more than 1 vCPU and they cannot use more than 512 MB of RAM, then you transfer those process IDs here. What is the command? The command is CG classify, control group classify. So if you know shell scripting, right, what we can do? For, this is a for loop, process in, so I'm printing all the process list. You can see PS-A, pipe, AWK, print. It means it will print all the PIDs. And PIDs are in first column, so printing $1. So each process I will take and put it into command CG classify. So every process will be put into this group known as 1V, 512, M1, 10D, 1N. Again, I'm using a command line argument dash tk $process. It means that if they create child processes, they will also follow the same thing. And done. Now all the processes are in this group. They cannot use more than 1 CPU and 512 MB of. This is control groups. Very easy. You can repeat this experiment and see how this thing happens. If we know control groups now a bit, now let me move towards the Docker description. We know the basic about C groups. Now Docker we can read. So this is a brief overview from the Docker website itself. So Docker is an open platform for developing, shipping, and running applications. Now you might ask me this question, sir. You said restrictions, isolated environment. They are talking about developing, shipping, and running applications. Yes. See, this is how Docker is advertised in the market. That people can create their lightweight applications, right? And they can supply those applications to their customers in the form of microservices, right? So every Docker service, whether it is Ubuntu, Apache, or a new website you are creating, they all are known as Docker images. So what do you do with those Docker images? The Docker company provides a repository known as Docker Hub, where you can download already available images, or you can even upload your images, which you have created in the form of websites, applications. So others can also download them, or you yourself or your customers can download. That is known as Docker Hub, right? So Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. Remember, I was talking about virtualization, but Docker today is the best mechanism of delivering applications to the customers. Right? With Docker, you can manage your infrastructure in the same ways you manage your applications. By taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. So once you create your image, upload it on Docker Hub, ask customers to download it and directly run it. That is very easy. So let me directly come to this diagram. Docker daemon, name is Docker D. This is the actual Docker server which is running. What it does, it manages images, it creates containers, network, and hard disk data volume. How do you talk to a Docker daemon? You can directly talk using command line, or you can also talk using HTTP, right? REST API, HTTP. Another diagram which will make things a little bit more easier is this. Let us first focus on this middle box. I am creating containers. How many containers I have created? 4. Creation of containers is similar to creation of virtual machine. There is nothing different. Even it is easier and faster. So I have created 4 containers. These are empty boxes. What I'm going to run in these containers? I'm going to run Ubuntu. I'm going to run Nginx, Apache, any kind of these software. They are available as images. If they are not available, I can download them from the registry. ये जो registry है, this is known as Docker Hub. So many images are available there. You can download any one of them for whatever your purposes. So you put these images in the containers and you are ready to run. Now these containers are running those applications which you wanted from registry. Now, if you say that, sir, the web server is ready, I want to put my web pages. You can put the way you put on Apache website or Nginx website, but containers will remain lightweight, right? So Docker daemon is running. It is creating containers. You are pushing these images into containers. From where did you get these images? From Docker Hub registry. Okay. These are the popular command on Docker terminal: Docker build, Docker pull, Docker run. Build is creating containers, pull is pulling these images, and running is running the containers, right? Now a bit about theory behind Docker. So this one, what is the underlying technology of Docker? So Docker is written in Go. I hope you might have heard about this language. This is very popular today, and takes advantage of several features of Linux kernel. The first feature is namespace. What do we mean by namespace? Namespace means what kind of names you understand. Any process understands. You might have heard about namespace in DNS. DNS understands .com, .org, right? .in. Similarly, a computer has namespace in which files can be named in certain convention, right? Similarly, Docker says that I understand 6 types of names. 6 or 5? 5 types of names. First one is PID. So Docker understands process IDs, network interfaces, inter-process communication, mount, and UTS. UTS is time sharing system, right? Given time. These 5 things of a Linux kernel, it understands. There are many namespaces on Linux kernel, but these 5 it understands. So everything which you do on Linux kernel related to these 5 can also be done with Docker. So this is a good thing. Second thing which Docker is built on is control groups. We talked about it. I gave you how to install control groups, right? Third thing which Docker uses is union file system. Union file system. This is a very interesting. I said you will create a lightweight image of Ubuntu, then Apache, then MySQL, lightweight images. How will you keep those images on a disk? In the form of union file system. Union file system or Union FS are file systems that operate by creating layers, making them very lightweight and fast. So all these images are in the form of layers. They can be put there and they can have connections. What are the example of Union file systems? OFS, BTRFS, VFS, and device mapper. Device mapper is very popular today with Docker containers. This is the third thing you require in Docker. And last thing is container format, which is pretty easy. The format is libcontainer, right? This is the default format. So this is how you can run Docker and create your applications. This is pretty easy. Everybody should learn this. Okay. Anybody has any questions? No questions. Okay. So let us move ahead. I want to give you a bit on practical, Docker and Docker security. So I would like to tell you certain important commands quickly, which are useful while running Docker. This is visible, right? This diagram we have seen. Here you can see more on this. A Docker engine. So Docker can be run inside a virtual machine, even outside the virtual machine, right? Multiple applications. How do you install Docker? First, you download the GPG key, so that the verification can be done. Then install Docker container by doing apt get install Docker CE, CLI, and container.io. Right? These are the three things. Similarly, in C groups, we wanted three things, but you don't need to require that. They will automatically install. In reality, you run Docker Swarm or Kubernetes, right? I told you what is Docker Swarm and Kubernetes, right? So you look at this diagram, one machine which is master, there are multiple networks. They run Docker, containers, and the main master allocates jobs to those containers, right? This is known as swarm architecture, cluster, master, and multiple slaves. What are the kind of commands you may want to run on Docker Swarm? In Docker Swarm, you can run commands like initializing the swarm, right? Or joining any additional nodes in the cluster. Some of the nodes may want to leave. You want to see all the nodes which are available. Who are the nodes? Physical servers. Any node can become normal node to manager node. That is also possible. See, everything you are able to do by sitting on a single machine, right? All these tasks which you are running, how to create an image. Do you want to create multiple replicas? So one container is running and you want to create 10 replicas of it, can be done in a single instance. One container running a web server and those replicas are there. Now you want to create multiple replicas. Even network can also be created by creating more adapters. What about Kubernetes and what are the minimal commands one can learn, right? So Kubernetes is an open source container orchestration tool and means to coordinate a cluster of nodes at scale in production in an efficient manner, right? So only one small difference is there between Docker container and Kubernetes is that here we also have one additional terminology which is known as pods, right? What are pods? Pods are containers, whatever we call as master or slave there. Here the pods will run multiple containers on a single machine. So multiple containers can run on a single pod and then pods can run on a machine. Just this small difference is coming up here. So you can see there is a single machine. It has two pods. In Docker, there is nothing like pod, only containers are there, plain containers. Here, even containers can be grouped. So you have Kube scheduler, schedule the containers, Kube API servers to talk to these containers, see their performance, right? Kube controller manager, right? These are the three modules with which you can talk using API, directly source code. Otherwise, you can talk using user interface or command line interface, which is known as CLI, right? What kind of commands you can run? Kube ADM, which is administrator, Kube administrator to start the server. Any node wants to join, the same thing, joining, leaving, right? If you want to change the configuration of resources, you can do kubectl. Kubectl is very important command. Kubectl, what are the kube system, what are the machines available, right? Any new namespace you want to create, that can be done, right? One thing we saw there that how to scale, how to create multiple replicas. Same thing is here, kubectl scale dash replicas is equal to X. If you write, you can write 10, 20, whatever number of resources you want, you can do this. When you do this, you can also do this automatically in the form of auto scaling. Auto scaling, when you do, it says that whenever the resource utilization is this much, increase containers. Whenever the resource utilization is this much, decrease containers, and that can be done. So instead of containers, here we'll increase pods, and a pod can run any number of containers which you wish. Can you see this CPU percentage utilization, minimum number of pods and maximum number of pods are there. These are some very good resources which are available. I suggest you to read them, follow them, and create a knowledge base for yourself on the Docker platform, right? Now let us move forward and talk about our last point of discussion. If you have any questions, please stop me so that we can take up a couple of questions. Otherwise, what we'll do is we will do the last topic of cloud migration in little detail. Okay. We have 9 students here. So you had placements today, is it? Is it a placement season there, Dhruv? Dhruv, Parsh, Jay, anybody has anything to say? So I got the signal. Kirtan has started the recording, so nothing to say. We can directly start. Okay, so let me share the screen once again, and we are going to talk about this: migrating applications to public cloud services, roadmap for success. Right? This is a little lengthy thing. I'll try to make it simplify and give you the essence that what sort of application should be moved, what sort of application should not be moved. In some applications, we are not capable to decide whether they should move to cloud or not. So we should have certain steps to be followed. If we are successful in following those steps, we may want to move or we may not want to move. So this is known as roadmap to migration. This is not virtual machine migration. This is application migration. Think about a company which has everything on premise. They have their own servers, their own applications. Now they are planning to switch to cloud, that we will run all such applications on cloud. Whether they should do it or not is the question, right? And this question is in front of every organization today, because most of the organizations have already moved to cloud, partially or fully. There are many big organizations, they have standalone software, legacy software, or software specifically customized for them and infrastructure, then whether they should move or not. So this is the thing. This is a very important document written in February 18 by Cloud Standards Customer Council. It has certain 6 steps which should be followed before doing any cloud level migration. First, assess your applications and workloads. What kind of applications you have, what kind of workload you run. Then build a business case. What is a business case? Think from the business perspective, that what will happen if you move from here to there, what changes you require, what additional benefits you get, right? What is the cost and saving, all these things. Develop a technical approach. This is a little different from the business case. The technical approach suggests what changes from the technical perspective: languages, databases, tables, right? Normalization and servers, kind of connectivity you require, right? And if you're going for a SaaS platform or PaaS platform, then everything changes, right? Is it a complete change? Because you may not want to move legacy applications, or you may want to create wrappers to run all legacy applications which are available, right? Adopt a flexible integration model, right? The integration model should always be flexible, but that requires careful investigation. Then there are multiple issues related to law. legality, compliance, right? And security and privacy, data residency, right? You are creating a service which stores a lot of personal data of Indian citizens. Can you keep that data in servers in US, Europe, China, right? You need to think about data residency requirement. Second thing is, can you retain the data? For how much time you can retain, right? How that will be specifically designed so that automatic deletion happens. And when deletion happens, there is no recovery possible. In certain cases, when deletion happens, we want recovery to be possible, right? All such things. And finally, managing the migration, actually doing the migration for a small prototype. If it is successful, then move towards all such applications. This is a very good document. Anybody who is preparing for companies offering cloud services should always look for this document, so that you can answer many questions which they have for related to cloud applications. They also talk about some cloud ready workloads and give an example that how migration happens for a specific application. So let me move forward. So this is theory. We already discussed a bit on this. Why somebody moves to cloud is we all know, but just to reiterate, greater scalability, making access easier by a mobile workforce, business agility, collaboration and flexibility. Agility is very important. You might have heard in software engineering, agile. Agile means always ready to get feedback, always ready to change, right? Many of the software companies do not like changing requirements. So the model has been completely changed. You should, whether you like it or not, you should always be ready to change, right? That is agility. Improved security. This is a discussion of discussion, right? Whether you get improved security or the attack surface becomes bigger. Better analytics on application users, reduce software maintenance effort, improved availability and responsiveness. This is an important point. Yes, availability and responsiveness has improved, right? Improved compliance with laws and regulations and reduced infrastructure costs. We agree with these, right? So why this is happening? Because rapid elasticity, auto scaling, pay-as-you-go model, right? All such things. Now there are certain concerns. People are worried about security, privacy, and data residency. Loss of control. Everything is managed by provider. In SaaS and PaaS, this becomes very, very important. Integration, right? Think about a banking website. They may not want to move to the cloud completely. They may want to still run their financial major operations on the on-premise servers. In that case, there are some services which are running on-premise. There are certain services running on public cloud. Even on a public cloud, multiple modules are running. How to integrate them is always a challenge, right? Availability and reliability of cloud applications. So you see that I just now said that responsiveness and availability is good, but there should be ascertained. They should be fixed up. Last point is cloud service provider lock-in. This is a very, very important point. Suppose today you move to a cloud by changing everything, because the cost model is very good. You even change the language, database, and everything is running fine. And after some time, the cloud provider increases the costs. And you don't like that cloud provider, but you can't move, because moving to another cloud provider again requires everything to be changed. And the technology in which you developed your website is only provided by that cloud provider, then you will not be able to move, or if you move, you require the whole thing to be developed again. Then you are locked in. You are locked into a specific cloud service provider. This is not a good situation. We should avoid it, right? So these are advantages and disadvantages. Now, what is the roadmap? These are the 6 steps which should follow. Let us complete the first step. Assess your applications and workloads. What kind of applications you run? What kind of workload you require? Do you have applications which require scaling? Like a company which is doing e-commerce, they would require it. On the other hand, a website which is just a website which is of a university, they may not require this thing, because they may have another application for admissions. Remaining thing related to university is available on a single web page, you don't require that. But still that can be moved to cloud. So instead of going into this, I will come to this table and I will want that each one of us read this table. What are the most suitable candidates and what are the least suitable candidates for cloud migration? Applications that are run infrequently but require significant computing resources when they run, most suitable, right? We require cheap computing resources. On the other hand, applications that involve extremely sensitive data, personal data, financial data, right? Particularly where there is a regulatory or legal risk involved in any disclosure, these at minimum require special treatment to be run in a cloud space. Though there are organizations today which run very sensitive applications there, but with greater control, right? Or in a private cloud. Otherwise, they would not run it. Business to consumer, B2C, is always, welcome because you may have more customers, less customers on other time. Applications now being run on the company's private network and that are very performance or latency sensitive, don't go on cloud. Applications used by mobile workers to manage their time and activity and which contribute only limited information to the company's board management information, office applications, simple accounting applications, HR applications, you should directly run on cloud, right? On the other hand, if there are voluminous transactions, financial transactions, don't run them, right? Different time zone, multiple development teams, right? Multiple people working together, all should go to cloud. On the other hand, applications which are running on legacy platforms, which cannot be converted, you are still using those technologies, they cannot be moved. And they can be moved, but you need to be very careful because they may require specialized hardware, specialized machines, right? Highly customized applications. Applications that require specific types of servers or otherwise inflexible about the type of computing resources. If you read this table, we could get enough idea that what should be moved to cloud and what should not be moved to cloud. Now, when you are identifying, then we need to see that, what is the business consideration, how the application will run, when it will maintained, changed, and finally retired. Applications also retire like human beings, right? What kind of architecture we should follow? It should be HTTP based, it should be standalone high-level language based, or it should be any framework based, right? Because of the limitation of time, I'm moving a bit because the first step is choosing what can move or what cannot move, and whatever you have chose as to be moved on the cloud, what kind of workloads they run. If you have identified those applications in an organization, now this is the time to build a business case. What is a business case? Business case will say that whether when we migrate from legacy to cloud, will it add some value to the business, or whether there would be return on investment. Remember that cloud is purely an OPEX model. What is OPEX? You just need to give operational expenditure from a customer perspective. On the other hand, if you buy servers, that is CapEx, capital expenditure, right? So that value should come directly. So the first thing is cost and saving analysis. So cloud server, when you go to cloud, what is the fees? How service management will happen? How security will be managed? Licensing, right? If the application has to be redesigned, what are the costs? Data and application integration, testing, deployment, maintenance, administration, everything involves cost and manpower. I hope you remember in one of the meeting, one of the session, we discussed this in detail. Then there are savings. These are the costs. What are the savings? Instead of buying servers, you are going to OPEX, from CapEx to OPEX, capital expenditure to operational expenditure. Savings on the handling of peak loads. There is a peak load. You can't go to the market and buy a server at that moment. Just buy more VMs, serve it, come back. Short cloud contract periods, right? So ideally, you should be able to cancel the cloud contracts and move to another cloud. That is ideal situation. Whether it happens in reality or not, that is a secondary thing. Ideally, this is an advantage. Staff reduction of reassignment, right? Because you are moving to cloud, server administrative staff will be, restructured. Cost saving analysis. So what are the costs? What are the savings? Then service levels. We need to decide the service levels. What are service levels? What kind of service we actually require? Response time, availability, right? Performance, security. These service levels should be defined. Privacy, there are no specific indicators, but the GDPR regulations or Security Act, which we have in India, they should be followed from the privacy and regulatory compliance perspective. When we do all this, will business improve? This is the very important question. Will there be an impact on revenue? Will we get more customers? Will customers be satisfied? And time to market. You are developing, you are having e-commerce applications, or you are having business products or education products. The way you develop them and ship them, will they change now because you are going to cloud? If those impacts can be evaluated, that is very good. And when you move to cloud, there will be, training required. Users will have to change their way of working. All these things have to also be accounted. The next thing is develop a technical approach. The third thing, the first one was, identifying applications and workload. Then the second thing was creating a business case. Now we are going to the third thing, which is develop a technical approach. So where you want to move, it can be infrastructure as a service, PaaS, SaaS, DBAS, whatever application way you choose, that can be done. What are the kind of applications which are available with cloud providers? Are there readily created applications, or you want some modification? That can be done. So PaaS, IaaS. IaaS is pretty simple because you are getting infrastructure. Then you can migrate everything which you require inside the virtual machine, right? PaaS, containers as a service. This became very popular after virtual machines, right? And everybody uses this. Here you require images, and then everything is smooth. Most important hurdles in migration comes in SaaS, software as a service. Function as a service is also available, right? DevOps, you might have heard about DevOps. This is more related to managing applications, server administration, analysis, testing, maintenance. All developer operations are combined, right? Common technical considerations, skills. Do you have skills to migrate? The security features which you require, are they available, right? Or this provider provides whatever security you require, right? That is very important. Security is a very important concern. Then these 4 points, first one is integration, monitoring and management, scalability, availability, and backup. What is the offering of cloud provider? When we are considering this, what is our requirement? What does it offer, right? That should be done. Similarly, people also use patterns. You might have heard about patterns, right? So cloud providers already created patterns. Patterns means templates, that you are a kind of this organization, you have this kind of web services, follow this pattern of applications, will move it, right? So patterns are templates, right? Deployment models. Fourth step is adopt a flexible integration model. So when you want to, move, you will have multiple insider machines, outsider machines, customers, vendors, contractors, who will all use your services, because this might be an ERP application. enterprise resource planning. This might be a customer relationship management application, right? So what you need to do is multiple interesting things have started, like performing an end-to-end workflow that crosses the boundaries between multiple business capabilities or systems, like e-commerce application, thousands of vendors, thousands of products, right? Millions of customers. Sharing of common master data, single sign-on is must. Monitoring an application in the cloud using a suite of on-premises IT tools, because from sitting in your company, you should be monitor your cloud or your applications. And API management. So you may want to migrate from cloud to another cloud or cloud to on-premise, right? These are the connections. So mostly agility is followed, right? Small integration model is agile model. Coming to step 5, that we need to address legal compliance, right? Any regulations government forces us to do, follow all such things. So compliance, security, and privacy are key issues that concern cloud service customers the most. And data residency has been added to the mix in the last few years. We are all worried about the data, how much time they keep the data, right? Data residency requirement. So these are very, very varied issues, right? Whether cloud service provider has firewall, intrusion detection systems, IPS systems in place, they do load balancing or not, how much retention time they have, what will happen to the logs, will I get the logs, will you give the logs, will you use the logs, because logs have a lot of information. A cloud service provider has my logs and I run a website. So whatever number of customers come, it is there in the log. All the network IPs are there. Kind of traffic which is coming up, right? Many things can be deciphered. So we require security from that perspective, right? So kind of a stress testing on this CSP, that what will happen if attack happens, what kind of attacks it can stop, right? Well, who will share the responsibility, who will pay, right? All such things have to be decided. These are very important customers. Important discussion related to security and privacy. If you run a website which stores user private data, name, date of birth, all related things, even biometrics, and if it gets leaked, you are in trouble, right? So this is a very important regulation by European Union, GDPR, you might have heard about it, General Data Protection Regulations. This came in 18 finally, and after that many countries started looking at this. You might have heard cases related to this. Because first time they started talking about this in greater detail. Data residency. The set of issues and practices related to the location of data, end metadata, the movement of data, geographies, jurisdiction, and the protection of the data against unintended access and other location related risks, right? Where the data will reside, for how much time it will reside, who will use it. Because Indian government would not want that an application which is providing such and such service, the data is kept in a country, another country, right? They have even given the guidelines related to this for certain specific government applications, right? Once you fulfill such requirements, you can directly come to the next step or the final step, managing the migration. Finally, having thoroughly defined on paper why, what, and how of the application migration project, the IT department can plan, execute, and manage the actual application migration. This is not a 1 second thing, right? It requires time. Executing a migration is a complex and delicate project, and as such, it should have a formal project plan and a skilled project manager, right? You might have heard about PERT CPM, project management, methods, right? Similar methods can be done here. One small recommendation: in general, it is recommended to conduct a pilot for one or two suitable applications, test thoroughly, document the lessons learned, and gather customer feedback so that improvements can be made before going live. So this is what the migration is. and they give the whole thing, whatever we have said in summary again here, what kind of workloads they can run. So IoT, big data in analytics, collaboration, development and testing, sporadic and seasonal compute intensive applications like physics, chemistry, experiments, storage, right? And then the strategy, the 6 steps which we have followed, they have given certain applications on which they have tested this, how interaction should happen, how teams should meet and do all such things. Finally, one thing I would like to say that execute mock migration. This is the step which is written on this page. If this is not successful, you can rethink whether you want to do it or not, right? Okay, with this, we stop here. I hope you get a fair idea on whether the application should be migrated or not, in what sense.